First of all, to find the average value, we have to have that formula memorized. But the truth is, you probably already kind of have it memorized, because how do you find the average value of a bunch of numbers? You add them up and divide by how many numbers there were. Well, our average value calculus style says I take the numbers and I add them up calculus style, meaning we're going to do an integral. And then I divide by how many numbers there were. Since I'm on the interval from 1 to 3, the width of that interval becomes sort of equivalent to how many numbers there were. 3 minus 1. And we're going from 1 to 3. I picked numbers that would work out pretty nicely for us, just to get started. So 3 minus 1, I'm looking at 1/2. And the antiderivative of 3x squared is x cubed. And then I'd be going from 1 to 3. 3 cubed is 27, so I'll have 1/2 of 27. 1 cubed is 1, so minus 1/2. 27 over 2 minus 1 over 2 would be 26 over 2, or 13. Now I want to look at this second part. So finding a value of c such that f of c is equal to the average value, first of all, there's a theorem that tells us that we're guaranteed to find such a c so long as our function is continuous and differentiable on our interval. And that's the mean value theorem for integrals. And just like that mean value theorem back from 17a, there's a formula and there are conditions. And our conditions are very much the same as our conditions were in 17a, that our function's got to be continuous on the interval. Well, 3x squared is certainly continuous on the interval, so we're guaranteed to be able to find this value. Well, what that looks like graphically, if I sketched a graph of 3x squared, it does something like this. And we were looking at that interval from 1 to 3. And I know that the value at 3, that y value up here, is 27, and the y value at 1 is 3. So that 13 that we just found, somewhere in here, so what this means is we're looking for what's the value here such that the value of the function is equal to its average value on that interval. If we plug c into the function so that we've got f of c and we're setting that equal to 13, I'm looking at 3 times c squared is 13, or c is going to be, now what we would actually get is plus or minus the square root of 13 over 3. But because we're on that interval from 1 to 3, we're going to disregard that negative value. It's not within our interval. So the c we're looking for is the square root of 13 over 3. F of x is equal to 2 plus 6x minus 3x squared. And we are being asked to find numbers b such that the average value on the interval from 0 to b, so we want the average value on 0 to b equal to 3. And the catch here is what we're trying to find is a value for b. When we're done, our answer is going to look like b equals. Let's get started with our average value formula on 0 to b. Well, on 0 to b, that means I'd have 1 over b minus 0, and then our integral from 0 to b of the function. 2 plus 6x minus 3x squared dx. And we're going to set this equal to 3. There's not a whole lot I can do with that 1 over b minus 0 at the moment. I'm just going to leave that as 1 over b. We can go ahead and get started integrating this. So the antiderivative of 2 with respect to x, I'll have 2x plus 3x squared minus x cubed, and that's all going from 0 to b. When I plug in b, I will end up with 2b plus 3b squared minus b cubed. It's not always the case, but in this case, when I plug in 0, I would get 0 plus 0 minus 0. I'm not going to bother writing all of those zeros. At first I saw this and I went, wait, we're going to have to solve a cubic, but that 1 over b up there is going to save us. If we distribute the 1 over b through, I'd have 2 plus 3b minus b squared is equal to 3. And hopefully this is a quadratic that factors. Personally, I know it's dumb. My brain has trouble factoring when there's a minus on my squared term. So in this case, I would move everything to the right-hand side just because it's easier on my brain. I would have, you all are younger. You're probably fine with that negative in front of the b squared. I've got b squared minus 3b. When I subtract the 2, I'll have plus 1. Well, I was really hoping this was going to be something that factored, but unless I've made a mistake, I don't think this thing is going to factor. If I did make a mistake and you see it, please write it in the chat. Otherwise, I'm going to assume that I've made it this far okay. If I have, then the only way that I know to solve this is quadratic formula. I am looking at b equals negative b, but our b term is that negative 3 in our standard ax squared plus bx plus c kind of form for using quadratic formula. So negative 3, but it'll be the negative that. So I'll have positive 3 plus or minus the square root of negative 3 squared minus 4 times a times c all over 2 times a. Oh, not a, or a was 1. I would be looking at 3 plus or minus the square root of 5 all over 2. And just remember that for your quizzes and your midterm, you won't be expected to put that into a calculator. This answer, totally fine, quit there, move on.